Hello, it's me. It's Sunday afternoon. I meant to record it a little bit earlier than this, but I didn't, so here we are. This video is for all my year 10s that have an assessment tomorrow or later in the week, but also for anyone revising any element of Unit 12 of the EdExcel GCSE. So I'm going to go through, there's a worksheet in the description below. Now I strongly recommend you print that out or download that. Attempt all the questions first, even if that involves pausing the video now while you do that, because when you're learning, the best way to do it is with the questions having been attempted first, so your brain knows what you were trying to achieve. Then you can find out whether you were right, whether you were nearly right, and you can improve on that by looking at as I go through each question. I'll be going through each question live on the screen here. If you're wanting to do it along, maybe you've already had a go at the videos and you're watching live, maybe you're not live but you're coming on this afternoon and just wanting to watch the video. How you do it is up to you. I can't force you to do it any which way, and you don't have to do it. However, I think the best way you can do this is to do the questions twice, do them, then watch how I do them, maybe mark the questions as you go along, then start completely blank sheet of paper and try and do them yourself without my help a second time. That way you're checking your improvement and making sure that you understand them a bit better. I'm obviously available for emails. You can see down the bottom of the screen. I think it's that side. Trying to check. 10 seconds time I'll be able to see. But yeah, that's what we're going to be doing today. So let's get cracking on with it. So the intro never lasts as long as I think it will. So here we go. We're going to go straight over to question 1, which is just here, and I'm going to put myself in the bottom corner of the screen, and off we go. So we're going to looking here at the non-calculated questions first, and here is question 1. It says ABC and XYZ are triangles. Now we have to show that they are not similar. So if we're trying to show something is not similar, we're trying to show that the angles are different. At the moment we've got some angles, but we need to show that they're different, and so to do so we need to find these missing angles. So I'm going to do 35 and 63 is 98, and I think 180 minus 98 is going to leave me with 82 degrees. So I think I've just worked out that this is 82 degrees. I now do similar over here, 85 and 63 add together to make 148. Then when we add them together and remove from 180, you will notice that that makes 32, and 32 is not 35. You will notice these angles are different. We then have to summarise. This is only enough for one, so to summarise, therefore, not similar because, and this is very important throughout here, I'll be mentioning how important it is to say that it's because of this or because of that that they're not similar. Therefore, not similar because the angles are different. And to be similar, shapes must have identical angles. So that is very important that we keep track of that. Okay? Feel free to pause after question 1, or if you're ready, come with me. Question 2. We have now got the two rectangles are mathematically similar, and we can work out the value of x. So to do so, we need to identify that that is going to there, and this is going to there. So I like to do it like this. 15 goes to x in the same way 22 goes to 66. And I spot that that's times 3. We check these are all length, there are no areas or volumes involved, so it's just times 3. Therefore x is 45. That is all there is to that. We look at what that multiplies to, and it's 3. Therefore, look at what that multiplies to, and it must be the same scale factor because they're similar. If they're similar, that tells us there is a scale factor we can multiply by. Feel free to pause or come with. A small picture online has a width of 3 centimetres and a length of 4 centimetres. Now, we don't know that the picture is a rectangle, but I think it makes sense to imagine a small rectangle which is 3 by 4. And Louis enlarges the small picture to put it in his presentation. The enlarged picture has a length of 18. So we need to make sure that we match them up. The 4 was the length, so therefore the 18 is where it goes. So we need to now work out the width here. Now to do so, I'm going to do 18 over 4 and simplify. That's 9 over 2, which is 4.5. So I now somehow need to times by 4.5. The fastest way to do 3 times 4.5 is to do 3 times 4 and 3 times 0.5. That gives me 1.5, that gives me 12, so I'm going to say in total that's 13.5. So we've got the missing side of 13.5 centimetres. Don't forget your units, it can cost you marks. So we're just making sure I've got a diagram here to help me. Again, any questions, put them in the comments below the video. I will try and respond to any comments people put, or send me emails to the address that I gave you earlier on. So we're now moving on. Pause if you need to. Here are 4 triangles. Write down the letters of the 2 congruent ones. Now we know congruent means they are identical. So we need to know, first of all the angles. So I'm going to do some quick calculations. Now you can do this the long way. I am going to work out that adds to 109, so that's 71. I'm going to work out that adds to 104, so that's 76. They add to 99, so that's 81. And these add to 104, so there's 76. So immediately I can rule out this one for the wrong angles. And I always, because it says explain your answer, I've eliminated A because all the others have got the same angles here. Look, 81, 23 and 76, 81, 76, 23, 81, 76, 23. This one's got the wrong angle, so it's not right. The next thing we have to do is we need to identify which of these 3. And to do that, we need to know our 4 rules. ASA, SSS, SAS, and RHS, which is right angle, hypotenuse, and side. Now we haven't got any right angles, so we know we can't use that. We don't have all the sides, so we can't use that. In fact, we only have one side for each shape. But what we do have is that this angle and this angle have a 7 between them. So we look at the same 2 angles, 23, 81 and 6, 23, 81 and 6. We need the side that's in between the 2 angles we've chosen to be the same. We could do it with different angles, but we're doing the ones that are in between. And you'll notice, therefore, we can eliminate D and say that B and C are congruent, but we have to say how. By ASA. And you'll notice I've got circles and things to demonstrate why we got rid of A and D. Okay? Stating your reasoning is important. Moving on. In this diagram, ST is parallel to PQ. Now, for those people who don't like the lettering system, I've made a small mistake from when I was copying these across from a different thing. So it's KL is parallel to NP. That's a small mistake. So we've got that. That's where the parallel lines are. Then all of these are just also on the diagram. So KL being 3, all I've done is it shows it on the diagram and it shows it in words. So I'm happy just to use the diagram. It says explain why they are similar. Now to be similar, we know for A, what we're looking for is the same angles. And there's only one way to do that. It's to check every one of the 3 angles individually. So we need to show that and that each have a partner. So what I'm going to do is use different colours because it's a video to show you which ones are the same. First of all, those 2 angles must be the same because they are opposite. So we call that angle KML. Also, you could have written KML with a little hat in the middle. They both mean the same thing. Is equal to NMP, or the angle notation. It's probably best if I'm consistent. The angle NMP, because, and you must say your reasons, because they are opposite angles. Next, this angle is the same as this angle because of the Z rule. If we remember back to our alternate angles, that that makes a backward Z shape and the insides are the same. So we would say that LKM is equal to MPN because they are alternate. I'll accept Z angles, but I prefer you to learn alternate. Finally, I kind of want to get rid of the green highlighter so that I can then use a different highlighter to show you the other angles. And I've got this one, and this one. And that shows that those two are the same because it's another Z. This time the Z is the right way around. We can then say that KLM is equal to MNP because they're also alternate. Now, because we now know that all the angles are the same, that is a proof of similarity. Therefore, this is the symbol for therefore similar because of equal angles. Now, what part B is then saying is, well, once you know that they're similar, how can you work out the missing bits? We know that 3 goes to A. We also know that 4, because of where the angles are the same, we know that 4, if you imagine spinning this diagram round, and I don't know the easiest way to do it, but this diagram here, that if you imagine that this is like a spinning wheel, spinning that angle becomes this angle. So the 4 and the 10 go to each other. That's kind of important. And the B goes to 7.5. And so this is the red bit is the bit we're going to need to use. 4, I think, has been times by 2.5. So this needs to be times by 2.5. And this needs to be divided by 2.5 because we're going backwards. We want to go this way. So that's why A is 7.5 centimetres. And that's why B equals 3 centimetres. Because in order to work those out, you have to use the scale factors. If you're not clear on it, rewind the video back 20 seconds, 40 seconds. Watch it again, check you understand. And hopefully it'll make clear that the bit we need here is the fact that this 4 and this 10 are the scale factors of each other, or help us find the scale factor of each other. Okay, next question. Pause if you need to. We're up to number 6, and I think this is the last of the non-calculators. And it's got W, X, Y, Z as a parallelogram. And it says that M is the point where the diagonals WY, that's this one, and XZ, which is this one, meet. So we can see that M is the midpoint. Prove that MWZ is congruent. Now, to prove congruence, we need those 4 rules again. SSS, RHS, SAS, and ASA. Not ASS, that would be wrong. I would be making an S of myself. We haven't got any right angles, so we're going to get rid of this one. And in fact, one thing we know in a parallelogram is that this side is the same length as this side, and we know that this side is the same length as this side. And because it said it's where the diagonals meet, we also know this is a midpoint. Therefore, we could mark on these ones as well. We are trying to do this shape here, MWZ. So we're trying to do this triangle is the same as this triangle. But the other fact to remember that they are parallel lines. And if they're parallel, we can say that this angle here is the same as this angle here. And we can say that this angle here is the same as this angle here. Only as long as we state it. So we have to say MWZ is equal to MYX because they are alternate angles. We can then say WZ equals XY. That's the length of the sides because it's a parallelogram. Parallelograms have equal length sides. We can then say that MZW, which is the yellow ones now, and MXY. Now, if you don't like lots of letters, this is where you've got to really pay attention to what's going on. The yellow ones I've now marked in yellow. If anyone's colourblind, I do apologise. The orange ones I've marked in orange, but we have to say why, because they're alternate as well. There's a lot of use of alternate angles in Similarity. And once we've got that they're the same, we have an angle, a side and an angle, therefore congruent by ASA. Again, any of these questions, feel free to rewind, watch it again until it makes sense to you. You can also go watch often watch better YouTubers and see what they would have done and see if they can explain it in a better way than Mr. Harris can, because obviously I am just me. Right, moving on to the next question. You are now allowed your trusty calculator. I strongly recommend you use it. I see so many people in a calculator exam almost just ignore it and then doing calculations, which makes no sense to me anyway. It says A, B, C, D, that's the outside bit, and L, M, N, P are two rectangles, that's the inside one. It says there's a 4 centimetre space either side and an 8 centimetre space to the right. Are they mathematically similar? Now, to be similar, we have to have the same angles and we have to have a scale factor. So we need to, first of all, because they're all right angles and they're all rectangles, so firstly, all angles are 90 degrees. That's a good start. Next, what I want to do is isolate and draw the two separate ones. Now, I am going to draw, I take them away from each other, separate them out. So this one was 9 to 12. And this one goes, because we've got to add 4 each side, I think this goes to 9 plus 8 is 17 as the height. And I think this goes to 20. Now, the reason I've done this is because I want you to realise that when you have a scale factor, that number should go to there and that number goes to there using the same multiplier. But I hope you agree that 17 over 9 is not equal to 20 over 12, which does simplify to 10 over 6, or let's go even smaller, it goes to 5 over 4. Do we all, I'm not saying do we all agree like you're all going to suddenly go, yes sir, we agree. 17 over 9 does not simplify to 5 over 4. So the scale factor is not the same. Not the same multiplier. We know that they're not the same, if I could write, because those fractions, which should be the same, any other time, it would be that number divided by that number is the same as that number divided by that number, because we have to times every side by the same number. But it's not the case here, so it's not similar. To say whether something is similar, you've got to say, is the scale factor the same? Here, it isn't. So we know it's not similar, so we have to say not the same multiplier. Therefore, always finish it up, not similar. Okay? And it's because of the scale factor, which I have mentioned, that it needs the same scale factor. So you have to say why, but I have done that. So let's make it even clearer. Not similar, because not the same scale factor. Ready to move on to number 8? We've only got three left, I think. Here we have an L shape inside an L shape, sort of tucked up. And it says, we've got some numbers, work out the length of CB. And it says this time that it says they are mathematically similar. So we know that there is a relationship now. So this is saying CB, there's a relationship between the 55 and the 30 that is matched by the 48 and the something. So in order to do this, what I do is I find the scale factor by going, I'm going to probably write them the other way around because I want to go the small one to the big one just to make everyone clear on what I'm doing. 30 goes to 48 and 55 goes to something. So to find the scale factor, I do 48 over 30, but it simplifies if I divide these by 6 to 8 over 5. So what I have to do is now times that by 8 over 5 because the scale factor has to be the same. I got the scale factor by dividing, and remember you're allowed a calculator for these now. So 48, let's just check it. 48 divided by 30, and it says in my calculator 8 over 5 or 1.6. You can use times 1.6, that's also true. And when you multiply that, you get 88. You've got a calculator, so times it by 55 to get 88 doesn't need you to understand. Here you can see it's divide by 5 times by 8. But your calculator will do that for you. That's where I've got this from. It then says the area of the small shape is 500. And this is our first application of area scale factor. Area scale factor, I don't know if it's going to let me change colour or not. Maybe it's having a little bit of a tantrum, doesn't matter, we'll stick with red. Okay, area scale factor is the scale factor squared. However, we've just said the scale factor was 1.6 or 8/5. So we're going to now do 1.6 squared. And that's going to be 64 over 25 or 2.56. Remember, we've got a calculator, so we're allowed to use it, and I encourage it. We're now going to take our 500 and times it by 2.56. And I would give anyone a couple of marks here if I saw 1280. However, what you've got to check when you're doing this is it doesn't say the big shape, it says the shaded region. And you must think, when you are finishing questions off, you must also make sure you've got units. You must always look back and go, it's not, what is it asking me? It's not asking me the whole shape. I've now got to cut out this 500 to get just the shaded bit left. So my final answer must be 1280 minus 500 on my calculator is 780 centimetres squared, because I have to cut out or take away the bit I've already done. Feel free to pause, go back if you need to, or we're going to go on to number 9. Not that way, we're not. Not unless I hold control. Okay, here are two mathematically similar shapes. Again, notice what it's saying. It says they are mathematically similar, so we believe it. Okay, mathematically similar. But we're now talking about volumes, so we're going to remember, volume scale factor is the scale factor cubed. It was one thing we've been really mentioning an awful lot. The volume scale factor is the volume cubed. Therefore, to go from G to H, I know that I've gone from 180 to 31104 using a number. And I want to know what I use with 284. However, that's surface area. So this one uses the volume scale factor. This one uses an area scale factor. So we've got a little bit of complication here. So what I do is I write them all down. Length scale factor, area scale factor, and volume scale factor. And then I do some division. 311.04 divided by 180 tells me that it is 1.728 was the volume scale factor. But to get the length scale factor, I'm going to cube root that, which needs on my calculator needs a shift button. And that goes to 6 over 5, or if I press the turn to a decimal, it's just 1.2. So I cube rooted, this is what I did the cube root of 1728 because I wanted to get down to what it was without cubes. You can't divide by 3, it's got to be the cube root. Takes us back to 1.2. Now, to get the area scale factor, I do 1.2 squared, which is 1.44. So a lot of forwards and backwards, but that's why it's 4 marks, because we needed to use length, area, and volume scale factors. So I times this one by 1.44, and it will now tell me the area of shape, surface area of shape 8 is 284 times 1.44, and it doesn't tell, I checked the question, it doesn't tell me to use special units or anything, so I'm just going to write the whole answer. So surface area equals 408.96 centimetres squared, because it's area. When it's the surface area, we're going to use centimetres squared. So 408.96 centimetres squared. A summary of what we've done in that question. What I've done is I've found the volume scale factor, because we were given the 2 volumes, by dividing. I then cube rooted that to get the length scale factor, and squared it, which was 1.2 squared, to get 1.44, and multiplied the area by the 1.44 because that's the area scale factor. A little bit going on there, but nothing you can't cope with. This is the super hard question on here. But it's not too bad as long as we don't go, algebra, I can't do algebra, I'm going to put my head in a bin. Don't put your head in a bin. It's not going to help you. And if anything, there's not going to be room for rubbish in the bin once your head's in there. Depends how big the bin is, I guess. So, what we have to do is, whenever we're doing mathematically similar, we know that something has been times to make something else. So 4 has been times by the scale factor squared to make A. We know that. But the length has been times by something to get to here. And this is where we have to think back to our algebra. 2x plus 1 has gone to x plus 1, x minus 5. So what do we times this by to get this? And this is where I look at these bits are the same, but these bits are different. So I think to get there we have to divide by 2 to get rid of the 2, but times by x minus 5. So that's my scale factor. I've got to do that as my scale factor. Even though it's algebra, we still can, because I've got to get rid of the 2 by dividing by 2, and I've got to times by x minus 5. The x plus 1s are both there. But I want scale factor squared. So the area scale factor must be all of this, x minus 5 over 2 squared, which means I square the top, x minus 5 all squared, over 4. But it was already 4. So 4 times, we've now got 4 times x minus 5 all squared over 4. Yes, it's a bit fiddly, but they cancel each other out. So I will accept the answer x minus 5 all squared. But for the best students, you would realise, I'm going to expand that. That's x minus 5 twice. X times x is x squared. X times minus 5 is minus 5x. Minus 5 times minus 5 is for minus 5x. And minus 5 times minus 5 is plus 25. And that's x squared minus 10x plus 25. Is that an expression? Yes. Is it the area? Yes, because it's got to use an area scale factor. Is it hard? Yeah, it's level 9. I don't care. It's level 9, but we have to push people to try all questions. If you get it, brilliant. If not, you've lost nothing. This is just how hard it goes in the GCSE. It uses algebra in similarity because it wants to check, can you understand that similar shapes have a multiplying factor or a scale factor, and so it has been multiplied to get from one thing to the other thing. What has it been multiplied by? And then even here, remembering, well, the area is that number squared. So we square our thing here, and we did that here. We got the things, and it had to divide by 4, which we did. 4 divided by 4 is nothing, or 1, sorry. 4 divided by 4 is 1, so it just leaves us with the x minus 5 all squared. And that's the end of the thing. Now you just get me back on the screen. Hello! So that's it. All those questions. If you can get 30 out of 30 on those questions, you're ready. If not, what are you waiting for? Why are you talking to me? You shouldn't be talking to me. You should be rewinding back to the bit of the questions you can't do. Oh, I just don't know what to do with you guys sometimes. I hope you've got something out of today. I hope you find it useful. If you don't, well, enjoy your Sunday. And I will see some of you tomorrow. But if you're watching this in like a year's time, then obviously it's going to be, you're not going to be doing the same things as you were doing now. But it's all good and all helpful. Take care. Look after yourselves. I've been Mr. Harris. You haven't. Goodbye.